So hi, I'm Meha Jha. I am with Emerson. I work in our measurement division. So we have flow, temperature, pressure level, analytical, wireless technologies, as well as some software around equipment monitoring. And so I have mainly been focused on the refining side of the industry, but in the last year and a half, as this sort of wave of green diesel and renewable diesel has taken off, and refineries have been kind of the lead in investing in this. I have now been pulled in on a lot of green diesel projects, and I know it's kind of relatively sort of newer to our space, and so I've kind of put together this presentation is very kind of basic educational, sort of a 101 overview on like green diesel and what I thought from an HSE standpoint that you might want to learn. So I always like to just kind of check with the audience, let them know that's kind of what we're going to talk about today, and make sure that's kind of relevant to you guys. And so you'll hear me kind of, we'll get through these definitions, but I call it green diesel, but it's also known as renewable diesel, but so same terms, which we'll cover. So kind of going through we'll start with some definitions. So this is interesting because I did this slide at a recent refinery, and most of them were process engineers and reliability and instrumentation. So a lot of them weren't aware that there are such thing called scope 1, 2, or 3 emissions, right? To them, emissions is all one thing or aware, but for you guys would probably easily know that there's scope 1, 2, and 3 emissions. And this far chart to the right, I really like in terms of there's so many different approaches, right, to how people are looking at reducing scope 1, 2, and 3. So I have boxed the renewable feedstocks because this is one of the ways that we're seeing, corporations, like it may not be your site, for example, but as a corporation or as a whole, people are looking at, renewable feedstocks in production. So I always like to kind of show this for refining and petrochemical in terms of when it comes to sustainability, right? What are the different approaches people are taking after? And some are more traditional. So some you might be familiar with in terms of it might be something as simple as, well, not necessarily simple, but maybe traditional as implementing advanced process control, right? Around a distillation column, a fired heater, right? Those particular big energy consumers or emissions contributors. There's sort of a new thing, which you can kind of, or relatively new in the sense that you can see it at our booth with a lot of people adding, I would say more like reliability measurements around equipment. So like with wireless technologies, looking at heat exchanger monitoring to detect fouling, right? For example, so there's sort of that realm. Real-time data series. So y'all would have probably seen it depending on the sessions you attended. So we have it from a equipment standpoint, like a critical equipment, rotating reliability equipment standpoint where we see that. But here, there's a lot of, I've seen a few software companies like that have cloud-based emissions reporting, right, where they're pulling in from stacks and things like that. So predictive emissions monitoring. So we have that. Doug, have you presented that session yet? Is that this afternoon or? Okay, it was this morning. Okay. So predictive emissions monitoring. So you guys are probably familiar with SEMS on the stack, right? But there's this ability now in terms of analytics data, doing sort of a predictive side to that, understanding the process, kind of machine learning, artificial intelligence around there. So that's a new umbrella. Fugitive emissions monitoring, very similar to the asset monitoring with wireless. So this is like using an acoustic transmitter for sound to detect leaking pressure relief valves, whether that's venting to atmosphere or to your flare. So some of those are at our booth. Hydrogen production. So how many of your facilities have hydrogen production? Like you have hydrogen production on site for your facilities. So, that's considered now gray hydrogen, right? Hydrogen apparently now has colors, right? And so, but if your facility is looking at carbon capture, right, for that hydrogen production, then you get to go to blue hydrogen, right? So there's so many different ways we're seeing people investigate. The one I've highlighted in blue, right, is in particular what we're going to talk about today is one of those pathways people are looking at for emissions reduction is around the addition or conversion of using bio-based feedstocks to make petroleum-based fuels. For my chemical counterparts, they also are seeing bio-based feedstocks being used in chemical processing as well. I'm not as familiar with it because I play mainly in the transportation fuel side, but this is also beyond just refining or transportation fuels. So kind of to give you an overview of kind of the biofuel space. So, we have traditionally, people think of biofuels, they think of ethanol, right? It's been along for a while. You can blend a certain amount of ethanol. And then there's something called biodiesel. So if you look at the chart is a much easier visual to grasp, but there's biodiesel, and then there's now something called green or renewable diesel. So there's this traditional biodiesel and renewable diesel. People kind of confuse them all the time. And even myself, I'll sometimes loosely use the word, but there is a distinction, which I'll show more so in the next slide. But visually for biofuels, so there's ethanol, biodiesel, green, and renewable diesel. There's also what's called sustainable aviation fuel, SAF, sustainable jet fuel. And we'll kind of talk about that a little bit more. But you can see the EPA definitions of what they classify in terms of a biofuel and what that definition looks like. So when you look at the biofuels, you'll see between traditional biodiesel and renewable or green diesel, which is what we're focused on today, they use the same feedstock. But the actual production processes are different. So this next slide kind of covers it in a bit more detail. So traditional biodiesel has a very different chemical process that it takes to create that biodiesel. And that process has been around for a while. So you can see kind of there have been over 500 famed biodiesel plants in the world, as opposed to what's green or renewable diesel. So in 2017, there were about 15 in the world. Back then, in the US, there was, I think, 2 or 3 operating just about a year and a half ago. I think we're up to about 5 or 6 that are actually on production online. But the map I had in terms of from like the biodiesel database of announced projects or potential projects showed well over like 30 facilities just in the US. I mean, it's just rapidly taken off, some in Canada as well. And so it is growing at a rapid pace. So there's not that many plants in the world globally for green or renewable diesel. So biodiesel is very much the traditional. There were restrictions with biodiesel in terms of there were certain blend limits that were allowed with petroleum diesel, some engine compatibility restrictions. It also had oxygen, and that had added a component of complexity to storing and transporting of that fuel traditionally. Green and renewable diesel, which is what our focus is today, is considered a drop-in fuel. So that means there's no blending requirements. So it's compatible with the ASTM standards, same standards as like petroleum diesel that goes into a car, same compatibility. So no restrictions in terms of blending. The difference is that compared to petroleum diesel, bio or green diesel has about an 80 to 90%, up to 80 to 90% reduction on emissions for the whole life cycle. So I'll show that on the next chart a little bit more, but the green or renewable diesel, so if you come from a refining background, this is more similar to like hydrotreating or isomerization. The way the reactions are very similar to what you see kind of in the hydro processing side, like the hydrocracker, hydrotreating side. And so there's no oxygen in this. And then the thing about green or renewable diesel, the reason why you're seeing it take off so much, when I started about a year and a half ago, I think there was maybe 10 or 15 projects, and now there's over about 50 that we're tracking as potentially going to happen or not. There have been incentives by the government in the US that have made this attractive. And so if you come from the refining space, you're probably used to a capital project for a unit, whether it's some sort of unit revamp, upgrade, maybe being a 2 to 3 year timeline, right? In terms of implementation and all of that. Some of the projects that we are having to quote is asking for 6 months to build, to get up to build. So I have one right now that they're giving us specifications on feed and they are wanting to be up in October. Like they haven't even purchased instrumentation because these incentives, they're trying to capture it that fast. And so it's very aggressive timelines. What's also maybe different is these units with the current catalyst, they can only run about 2 years and then you have to take a shutdown and replace the catalyst versus we're used to 5 to 7 years on other units. But the thing about these incentives, you know, there's a lot of debate of when they will expire, how long will they last? So companies are moving fast to try to capture this. So for example, you're from Marathon. So for their California facility, their phase 1 is getting the reactor up right now. Phase 2 is adding a pretreatment in a year and a half. So some people are going, it's not like they're building everything at once. They may start with the reactor and just buy pretreated feedstock and then later add, but they're just trying to capture these incentives, state incentives and all of that while it can, because it's still cheaper to produce in terms of yield, in terms of the processing, in terms of the equipment, the capital investment. It's still right now cheaper to produce petroleum diesel, right? At the end of the day, the economics. So these incentives have to be in place to try to incentivize. So one of the things I will say is currently right now, jet fuel is not incentivized. There's not credit programs. Me from an Emerson standpoint, I'm hoping they'll do it because that means more builds. But for producing jet fuel, currently there is not an incentive in place. It's only for green or renewable diesel. It's what's interesting is you will see a lot of airlines, though, from a consumer standpoint, have made commitments to say we're going to consume a certain X amount of renewable jet fuel. So you'll see it from the consumption side, but we've not yet seen an incentive on the producer side. So that's hopefully something I hope will come. So this chart kind of also, again, tries to ground you on the fact that, you know, there are 2 types of biodiesel, but the emissions reduction and the benefits. So when we talk about this up to 80 to 90% emissions reduction, the way that that is kind of calculated and viewed, it is from the seed. So it's from like the crop, right? Whether that's soybean oil, the animal, the farm, all the way to tailpipe emissions. So the bulk of the emissions reduction comes on this sort of front end of manufacturing the agriculture-based, the bio-based feedstock, because the engine compatibility for the fuel is the same. It's the same ASTM specification. So your tailpipe emissions are the same, but across the entire life cycle is where you see the emissions reduction. So just want to kind of illustrate the benefit of, you know, why people are looking at renewable diesel and jet fuel in terms of that. Okay, so kind of start understanding the market. I think this does a good job of illustrating what I said of where we are at to the growth. So if you look at these charts from the EIA, it's almost it's about 8 times, almost a 10-fold of within 5 years of what the demand just for green diesel is going to grow to. And you can see like by region, right, by our PAD regions for refining that we're so familiar with, majority is on the West Coast. So California is the main state, California, Oregon, Washington, but California leading in terms of primarily where the green diesel is currently going and what market is using it, and the incentives are there. But you can see the estimated kind of current production capacities and the estimated. So really we're seeing just a ton out on the West Coast. Louisiana has some interesting project opportunities. There's one that's being announced about they're wanting to use like wood chips for the feedstock. And so kind of seeing a lot of different activity in this space. So one thing that maybe is also different is there's kind of different types of projects. So there are some facilities that are purely greenfield. So they're standalone, they're building pretreatment, reactor, loading, offloading racks. So they're kind of standalone. Those are usually like independent renewable companies that are trying in the space. Some are co-location where you are you have an existing refinery and you're adding a renewable diesel unit to your refinery. So you still have your refinery operations going, but you're adding a renewable diesel. Some are a conversion. So Marathon's, whereas Dickinson was a conversion, I think California was also a full-on conversion, where if the refinery was maybe deemed long-term in the portfolio as not as profitable or marketable, they converted it over. They reused a lot of the equipment, redesigned the hydrocracker, the hydrotreaters, the hydrogen plants, and used the loading unloading racks. And they basically, so have, yeah, Marathon Martinez was, P66 Rodeo. You can see some of these projects that they basically just converted the refinery over. And then sort of the co-processing with that, again, similar to co-location of kind of shared utilities. What I've heard is kind of interesting is, so you'll see the feedstock, a lot of it is, you know, like ethanol, soybean oil, like things like that, corn oil, soybean oil. Some people are even saying, some of my sales team that supports ethanol accounts, production accounts, were saying that some ethanol plants are looking at, like, instead of producing ethanol, just selling their feedstock to biodiesel. And that may be more profitable for them in the long run. So there's kind of just some of these changes that people are kind of exploring and investigating. And there's some articles coming out of if ethanol is really that like economic or like environmentally like as beneficial. And so it's interesting because we're seeing just a lot of different investments go on. So just kind of wanted to illustrate that. So this map kind of shows you where these facilities in the U.S. are coming or expanding. So the kind of more flagship original in the U.S., the Valero led that charge. That they partnered. It's in Louisiana, Valero Diamond Green. I think they're on their like 5th project or expansion. So they kind of were ahead of the market in the space of where that started. But you can just see all the growth that has rapidly has like come online, or where these investments are coming. This started in Europe. In terms of Europe has been doing this for a few years. In Europe, they call it HVO, hydrotreated vegetable oil. So green diesel is also known as that. We call it in the US mainly renewable or green diesel. HVO is maybe the term you'll hear more so in Europe. So Europe market, Total, Neste, some of those guys have been doing this, but in the US, because of those local state incentives that you can see here, that's where you're seeing this take off and where the opportunity is. So in terms of why are companies investing? So, you know, the economics behind it with all these sort of regulatory credits. For a refinery, there's the diversification piece in terms of you know, having a different sort of like the product slate around there. But also, if you think about, you know, with crude oil, right, it's always, refineries feedstock is just crude oil, but now you're looking at bio-based, right? So there's an alternative sort of feedstock for some production of your products. This Sustainability Accounting Standards Board, if you see the chart to the far right, it kind of shows some of the benefits in terms of water, waste management, air quality, and greenhouse gas emissions for producing green diesel. Knowledge in the sense of the reactions are similar to what refineries are used to compared to traditional biodiesel production. And then the co-location benefits. So whether you're even converting an existing refinery or sharing, you know, using hydrogen, your logistics and distribution, your tank storage, your loading, unloading racks, the wastewater treatment, like already having some of that capital investment, right, makes it kind of easier to kind of convert over or add this sort of capability. So when it comes to renewable feedstocks, the name of the game is very similar, I would say analogous to like what you would view like opportunity crudes, right? And being able to process different opportunity crudes. So there's a lot of maybe concern in terms of like when you look at corn oil, soybean oil, right? Some of these agriculture products, there is in terms of a supply limit or a competition with like food, right? Or other use cases. So right now I'm seeing some plants that they are just speccing soybean oil and corn oil as their only like feedstock to process, and they're designing that way, which is kind of a risk. And so we really talk about future proofing in terms of being able to accommodate different types of feedstock. And so each feedstock, not all feedstocks similar to crudes are weighed equally, right? So in terms of processing, right, if you think about used cooking oil, you don't know what you're getting with that. Like if they cook chicken nuggets, what they cooked in there, what that spike in the fatty acid content is going to look like, right? What the tan is going to look like for that. And so it's almost similar to refinery, like in terms of opportunity crudes of you are incentivized more, kind of the more difficult stuff you can process, right? Sort of the better the credits, right? So every every feedstock is not equal, right? There is a score based on kind of that life cycle assessment from seed all the way to tailpipe emissions, and then just with how difficult it is to process it. And so minimizing the carbon intensity will help you maximize your regulatory credits. Price being kind of a concern. So I think like in Europe, they're trying to shift away from using like the soybean, the rapeseed, and trying to go more animal fat. So there's kind of those changes based on agriculture and demand, and then supply availability. So right now in the US, the most dominant, as we said, vegetable oil, about 80%, and then animal fats, 20%. And there's also an optimization piece to this in terms of, do you stay closer to the feedstock, right? Like, do you build closer to the feedstock because of transportation, or your end market like California, right, where you're distributing there? So there's all these sort of factors at play. So the carbon intensity score, so for ESG personnel, this is different, because for a refinery, you know, you have your normal EPA emissions reporting, fuel gas consumption, permitting, charge rates, things like that you're used to. This carbon intensity piece is different. It's new because this is something that companies are looking at in terms of by site, but it's also tied to your credits, getting those government credits. So it's a new area of reporting. So when these projects are coming online, or when they're investigating, they're hiring these accounting firms that specialize in this kind of accounting, this sort of carbon intensity accounting. And what they're doing is they're evaluating, like I said, from seed all the way to end use. And so for this carbon intensity, it based primarily on feedstock selection is what dictates that score. And then there's the production piece, which is where there's some opportunities to improve in terms of energy efficiency, process conversion, and we'll touch on that a little bit more. But basically, you know, the lower the CI score that you can get, which is influenced by feedstock and how efficiently you operate, like convert that bio-based feedstock to fuel, that can dictate your score, and that can generate and help you optimize those financial credits. And so to do that reporting, if you kind of look at the like purple square, you know, you have to be able to accurately account for all your raw materials that go into making this bio-based feeds or bio-based renewable diesel. You have to have like, especially if you're at a plant where you're co-located, you have to know the allocation of what's traditional refining, what's actually going to that renewable diesel unit. So there's a lot in terms of reporting, hydrogen consumption, raw materials, yields, all of that go into this. So it's kind of a newer realm where, you know, at your refineries, you may have done your mass and energy balance and it's more for corporate or internal purposes. But in regards to green diesel, there is, because of the financial reporting piece, that is a difference there. So kind of looking at the process a little bit closer. So there's three main kind of process blocks or components that can be part of renewable diesel. So one is a pretreatment. So this feedstock, so for refining, right, for us, that would be just desalting, right? The desalter for our sort of crude pretreatment. But for renewable diesel, the pretreatment is very different than what we're used to. This is the one part that refining, or in our sort of continuous operation, we're not used to. The technology itself, the pretreatment technology, is more so similar to food and beverage. It's processes like degumming, things that we don't, I'm a chemical engineer, that we have just never touched. And I don't know what you know, I look at the vessels and I'm like, I don't know what that is. So it's more on the discrete side. So the pretreatment, the main purpose of it, though, it is a continuous process. It does not have like hygienic requirements like food and beverage. It's normal operating temperatures and pressures, like lower within range, but it's just it's like dewaxing, degumming, like absorption. It's just a lot of stuff that I don't really, you know, in a refining space, we haven't really touched. So that is one area that's kind of different. Marathon, I will say, is in particular because the pretreatment vendor they selected is actually very similar to like a desalter. They went different, but most other refineries, they're using a company called Alfa Laval or Desmet Balestra. They're out of Europe, the licensors for this technology. Marathon went with more of something that they know traditional process wise, but others have not. They've gone more into this sort of food and beverage type treatment. And what the pretreatment does is it's basically similar analogy to like desalter in the sense that you're getting rid of contaminants to not poison the catalyst downstream is what the purpose is. And so the pretreatment is really more so just there in terms of your goal is just to get rid of all the impurities and make sure the pretreatment runs like reliably. So there's not much optimization. It's not a money maker. It's kind of a necessary evil. What you'll see though is some companies will wait to put pretreatment, like they'll get the reactor online and try to capture the incentives and say that, okay, maybe in a year and a half, we'll add pretreatment. They may just buy pretreated feedstock, or what they may do is, for example, if they have two facilities that they're converting to green diesel or building green diesel, they may build a pretreatment between the two. So there's just so much variability to how people are approaching this, if they're going to bolt on or what, or if they're going to just buy pretreated feedstock. Obviously, having a pretreatment line gives you more flexibility, right, in terms of the type of feedstock you can process. The reactor section, so again, this is also a licensed process. So the people that are typically licensing, Haldor Topsoe is a big one that I've seen in the US where I've seen more people, but Honeywell UOP has this technology, Axens. Those are kind of maybe the three main sort of licensors. So people that we're familiar with in the refining space in terms of licensed technologies, but the reactor section and then offsites. So the difference because of the scale of like the volume of this stuff, whether it's on the feedstock or product end, most of this comes in truck or rail. So you're not dealing with like pipeline or ship like you may have in traditional refining. So it's mainly truck loading, unloading processes. I just like this chart because I think it's very, I took it from Alfa Laval, who's like that pretreatment vendor, but I like it because it kind of shows in a simple way, you know, the feedstocks, the byproducts that happen. So one of the things is wastewater. There's more wastewater management involved in this this reaction than traditional refining. But I just thought this was a really nice sort of simple diagram of what goes in and what goes out. It's more complicated than that, but I do like this this diagram. So from your guys' point of view, here's maybe some of what you're used to and have seen in traditional refinery hydroprocessing. So what are the HSE implications or differences? So starting with hydrogen, so the green diesel production process, similar to like we talked about with the hydrotreating and the isomerization reactions, this reactor process consumes a lot more hydrogen. So a lot of plants are being pushed on their demand for hydrogen. It's about 50% of the operating costs. So there are some, so quite a bit of hydrogen consumption. In addition to like hydrogen purity, people are monitoring H2S content as well. So having an analyzer that does both. But basically in terms of, you know, hydrogen consumption, needing more hydrogen, that is kind of, you know, one of the HSE impacts. So I did a session earlier where the EPA took data for refineries, and typically 6% of your emissions from a refinery come from your hydrogen plant, right? So if you're generating more or needing more hydrogen, right, there's like an emissions impact there, right? So hydrogen use is significantly more. This is this reaction is extremely exothermic. So from an HSE standpoint, in terms of trying to prevent a reaction runaway, so there's one project that we just did where I think the final number was 190 temperature transmitters on just the reactor alone to monitor for hotspots and for the SIS system. So like very critical. So some of the control diagrams I have read for this particular plant, like the recycle and purge gas ratio to like fresh feed is almost like 10-1. I mean, a huge recycle loop to try to keep this temperatures cool. What's tricky about this is if you are changing your feedstock, that changes that isotherm profile, changes the reactor temperature grid. So the control is very critical around preventing runaway. I mean, it's highly exothermic. And then the temperatures and pressures, you can see this is a very like up to 800 Fahrenheit and 1000 PSI is what we're talking about in terms of the instrumentation and what's going on there. But yeah, it was like 180, 190 transmitters. And I thought, oh, that seems like overkill, but I mean, very, very critical to try to detect hotspots or anything around this. So fired heater combustion, you guys are pretty much used to that, right? With your stack monitoring, your SEMS, but being able to improve that control impacts your CI score, right? And so if you can improve your CI score, which combustion optimization is one of the biggest ways, then you can typically improve optimize your credits. So the carbon intensity scores and credit reporting, we talked about that, the accuracy needed for reporting there. Corrosion, so there's more CO2 present in these processes, and then the feedstocks typically have a higher TAN. And so there's some differing corrosion mechanisms than what you have been used to seeing. So what people are doing, because these processes are going up so fast, and if some of them are repurposing existing equipment, they're updating all the materials like the metal of the vessels, the piping. I haven't seen as many yet put in online corrosion monitoring. They're kind of doing a wait and see, which is kind of a risky gamble, but these projects are moving so fast. So right now people are just updating all the metal piping, this and that. And so they're at least doing that on the design side. On the operation side, they haven't yet fully understood how varying feedstock is going to impact the corrosion of this yet. So it's kind of a wait and see, because as we said, I threw up that chart, like I said, only maybe 5 or 6 are operating in the US now, right? In terms of, a lot of projects are being announced, but, we worked closely with Marathon on Dickinson, and they had catalyst issues. It almost took them 6 or 7 months to get it up and running. And so things like that this is still relatively new to market, but corrosion is one of the big kind of concern areas that's been untapped. We mentioned this, there's more wastewater that's generated, especially on the pretreatment side. There's like a washing step in particular. So there's just an increase to wastewater management. So these are some of, from your guys' standpoint on the HSE side, of kind of some of the differing impacts and maybe what you've seen in traditional refining. So I like to kind of show this of, so the carbon intensity score that your companies are looking at when they're adding these sort of, whether it's carbon capture or green diesel to their sort of portfolio or their fleets, there's a piece where you can impact, scope 1 or scope 2 emissions. There's an HSE impact, and feedstock is a big piece of that. But then if you see here on this list, right, reducing your flaring, reducing carbon capture and or carbon capture, utility consumption, hydrogen usage, heater or boiler combustion optimization. Some of these are different ways to reduce, to continue to improve that carbon intensity score that comes from the operational side. And so this is a very really big kind of chart, but this kind of just shows or illustrates there's so many different kind of solutions or opportunities to do that. I'm happy to talk about it in more detail, but just wanted to kind of throw out there some of these different technologies people are using or implementing around this space. So wanted to talk about reporting, because that's a lot of what you guys are familiar with. So just a little bit of kind of the details. So there's these different types of kind of crediting when it comes to this. So, y'all are maybe more used to EPA emissions compliance sort of reporting, but, this credit reporting is new, as we talked about. So there's the fuel pathway sort of credit reporting, which is basically like you're producing green diesel, jet fuel, you're using bio-based feedstock. So kind of just the baseline. But then there's project-based crediting, which can occur at these facilities. So that's like things like looking at renewable power, like implementing renewable power on the grid. That can be carbon capture. So it's almost additional. It's in a sense of, okay, you do the fuel path, but then you're doing some different sort of ongoing improvements, and that's how you can generate credits. So there's kind of different levels to these credit generation opportunities, but there's also just different accuracy and data validation requirements. So one of those things, and I know y'all are probably used to this from if you did refinery sector rule, EPA compliance side of things, where you will see, data accuracy, meter calibration requirements. As I mentioned, almost a lot of those custody transfer. So it's different because maybe you would have done it for internal purposes before, but there is an external component to reporting this in order to get your credit. So these are just this is for California, the different reporting requirements that they require for these projects and ongoing reporting. So one of the things that I always like to talk about in general, from your side, you guys kind of deal with the pain of needing good quality data, garbage in, garbage out, trying to do your reporting, and often it can be a source of data entry errors, missing data, or measurement errors. Measurement errors, is really the disconnect you see between field and what hits your desk. And a lot of times to trace back to what is that impact. So with measurement errors, it can be typically due to three things. So the first is the instrumentation accuracy, so inherent in the device itself. So depending on the type of technology you selected and like how you installed it and how you maintained it and the calibration practices. And then the third is changing process conditions and compositions of materials can impact the accuracy of those devices. So in the case of green diesel production, so in a traditional refinery, I would say like 80 to 90% of the flow points are orifice flow meters, volumetric based flow meters, orifice plates. And the challenge that we're seeing with, I've had some refineries where they said, oh, we only used Coriolis on custody transfer, but we've had 2 Coriolis meters before. This was a small refinery. Now we have like 30 for green diesel. So we're seeing a lot of people having to invest in mass-based Coriolis technology, because if you look at kind of this chart, when it comes to volumetric flow measurement, you can see from the flow equation on the far left, you can see how temperature, pressure, and changes in pressure impact all of these variables that you're using to calculate mass flow. So when it comes from accuracy of reporting, changing the fluid, like if the changes in feedstock, that impacts your accuracy. If you're changing pressure and temperature of your process conditions, that impacts accuracy. A lot of times people kind of make this mistake of thinking, well, to get from mass and volume, you need density, and they assume a constant density, or they take an average of density. But if the actual process fluid is changing, then just correcting density based on temperature and pressure for your calculations results in inaccuracies. The other is some of these plants you saw, they're being built out in the West Coast. Marathon is up in Dickinson. It's a very cold climate. And so plugging of impulse lines creates inaccuracies, things like that. They've implemented a lot of Coriolis meters to kind of avoid some of those misreadings or errors. So, mass-based with Coriolis, independent of changing fluid properties or process conditions, no compensation. And so this is something that we're seeing a lot more, I guess, accuracy of these units in terms of control and reporting. We're seeing a lot of people within the process block use Coriolis meters. I'll touch on this very quick of just, there's the changes in environmental reporting compared to typically you would have to, for most meters, pull them offline, maybe put a spare on as you send the other to the lab to calibrate or to verify. Like Coriolis technology, as well as mag meters, if you ever use them for water, they have diagnostics embedded in them that allow you to verify the accuracy online while in operation without stopping the process, how frequently you want it. This is something that the EPA phrases it as manufacturer's recommendation as an accepted approval method. So these are methods that are approved by the EPA and other custody transfer regulatory agencies in terms of you can verify the accuracy. So we looked at the LCFS reporting, right, and saw there were certain accuracy and calibration requirements for these meters reporting hydrogen, fuel gas consumption, all your products and things. So this helps in that realm in a sense of you can easily, at the push of a button, have this sort of verification that you're within factory standards, and you can have a report generated, which is like what that screen capture is for this. So we've seen people adapt this as well. The last thing, kind of touched on this before, right, again, is just, then the CI reporting with better measurements. And so that really ties to the energy and process conversion. So whether you're at a green fuel facility, if you're at a chemical plant, petrochem, refining, right, a lot of these areas are areas that you're looking at improving in terms of reducing emissions or improving energy efficiency to reduce emissions. And so that is still another area for HSE in terms of it's not just feedstock selection, getting this green diesel reactor up and running. There's also a continuous improvement that can impact your score and help you optimize credits better. So I just wanted to point out, this is emerson.com biofuel solutions. This has some more material if you want to dive in deeper to green diesel to learn more about it. These have some like really basic kind of challenges, future proving, matching technologies to solutions. There's different kind of white papers, podcast things we have out there. I will also be at the booth. I'm happy to answer questions. We have different technologies you can see that are being implemented or anything like that. With that, are there any questions, comments? Yes.
Work for Marathon in California.
Yeah.